Okay, so to pick up where we left off last time, we were looking at logical operators, and we just introduced these logical operators: the and, the logical and the logical or, 2 ampersands or 2 vertical pipes here. And there is an order of precedence here. To demonstrate what I mean by this, what if you try to combine a combination of these these 2 operators? First of all, I've set A to be true, B to be false, and C to be false. And so what if I just straight up do it like this? Well, reading this left to right, I would say true or false. So that's the entire thing is true, right? 1 or whatever. And then this is going to be false. So is this going to be true or is this going to be false? What's it going to print here? True? Let's find out. True. Why?
Because A is true.
A is true. Okay. So then we can ignore the rest of it. That is something called short circuiting, and we will talk about that momentarily. But there is an order of precedence here, right? What is actually getting evaluated first? Well, order of precedence, PEMDAS rules. Remember that multiplication gets done before subtraction or addition or something. And so the logical AND operator is actually going to happen first. So what happens here is that B and C is evaluated. Well, what's the truth value of that? False. So what now you can see that it's true or false, which evaluates to true, and that's why we were getting true before. Okay. Now what about this one? I've changed the order of operations by placing parentheses around we call that a disjunction, a logical or, right? So now what I'm doing is I'm throwing out the normal rules of the AND operator having a higher precedence, and now I'm saying evaluate those things in the parentheses first because of the P in PEMDAS, parentheses, right? And so now what gets evaluated? A or B, right? And that's going to be what? True. And then and C is going to be true and false is going to be false. And so we get different answers out of both of these, right? So you do have to be careful with your order of operations. Just like with math, go ahead and write more parentheses if you need to. Even if you don't need to make it more readable, with your logic you also need to do that as well. So the order of precedence generally is left to right. Generally, the operators are evaluated left to right, right? But then the order is going to be, one I didn't have there was that the negation operator comes first, then the and operator, then the or operator. So you may need to add parentheses for correct logic. And this is true in both languages because math is true in both languages, logic is true in both languages, and so it's going to have that order of operations no matter what. Okay. There's also something called short circuiting. Right? So consider the logical AND operator. If I just have 2 operands now, A and B. Right? Now consider just A first, because again this is read left to right. Right? Let me indent there. If A is false, does it matter what B is? Nope. So consequently, B does not get evaluated. Now B could be a variable and it doesn't even look at the variable, or it could be an entire expression and it doesn't even bother looking at the expression, right? And why is this? Well, it's efficiency, right? That if you think about 40, 50 years ago, if you knew that an expression was going to be false right away, right, and this is going to be false because A is false, then do you need to waste CPU cycles, which were measured in seconds at some point, right? Do you need to waste those CPU cycles in order to evaluate the rest of the expression? No, you immediately know that it's going to be false. So you know the computer, you know the entire thing is false, and so you skip some operations to save time. Right? Now, 40, 50 years ago, that mattered, but it doesn't matter today. But it's still ingrained in every single programming language from 40, 50 years ago that it's come to be expected, right? This is a common idiom. Common idiom is used in many applications, right? So for example, let me just go ahead and go into Java mode here. But before we do that, what is an idiom? A saying, a colloquial metaphor, right? Something that doesn't necessarily have a literal translation, like raining cats and dogs is the one I usually go to. It's not literally raining cats and dogs. It's an expression used to denote that it is raining hard. Well, if programming is like any other language and we have punctuation, sentences, paragraphs, we also have idioms, right? And so one of our idioms is to use this to our advantage. What if I had in Java an integer that was null, right? Now it's dangerous to do anything with that. If I were to do something like this, int y is equal to x plus 10, right? Is that going to work right there? No, why? Because what's null plus 10? Not null, yeah, right, something. Right? The computer is not going to be able to handle that at all. In fact, the compiler will not catch that. It might warn about it, but when I go to run it, I get a null pointer exception. I can avoid that by checking before I do this operation. If x is not null, and I don't know, x is equal to 20, then just go ahead and add this to y. I don't know why I would check the second thing here, but this is to demonstrate short circuiting here. Now, am I going to end up doing this operation here? Nope. So I end up looking before I leap here, and I don't get that null pointer exception. It's still giving me warnings about it because the compiler is smart enough to see that x is null and you never actually changed it. Right? So it is used as a common idiom to do error checking. Right? This would actually be an error right here. Right? Why? Because if x were null, then could I check to see if it was 20? Nope, that would end up being a null pointer exception in that one area. Right, let's go ahead and show it like this without that error check right there. I would still get that null pointer exception. But by looking before I leap, right, it's not null. Oh, okay, if it's not null, then go ahead and check to see what its value is. But it is null. We're not going to do the second operation here at all, resulting in that null pointer exception. So let me save this and run it and show you that there's not going to be a null pointer exception here because of short circuiting. Yeah?
If you had it x equals null, and that's the only thing you changed, would it still give you that pointer exception?
Yes, because that will be now true. And so we have to determine, well, what's the value of this? Because we need to know, is it true or not? And so, yes, we will get a null pointer exception. Right? Usually, you don't want to, I mean, if you're wanting to see if something is null, that's the only thing you end up checking because if it's null, you can't do anything anymore. Right? Well, the other types of short circuiting is with a logical AND, the logical, or A or B. Well, here the situation is if A is true, does it matter what B is? Nope. Why? Because you just need one of these or the other or both to be true. And so, consequently, B does not get evaluated. And again, the same thing. Every single programming language, 99% of them, I should say, does short circuiting. Right? Again, saving the CPU cycles is not as important. It's still important to this day, but it's not as important as it was 50 years ago. But this idiom, this common understood thing that all programmers understand happens once they get into it, they're going to expect it in another language. We had it in C, so we wanted to make, Gosling wanted to make Java look familiar. And so, of course, they're going to incorporate the same features as other languages. Every programming language that I know of does this. This is an idiom, right? All right, so let's see. Some other pitfalls here, and then we'll do an exercise. Pitfalls. Right. Consider the following C code. All right. And let me go ahead and cut and paste it, consider, so I get it right. There we go. What's going to happen here? Now A is 5. Clearly what I'm trying to determine is, does A fall between 0 and 10 in the number line, inclusive on 0 and 10? What's going to happen here?
It will print
It will what?
foo. It will print foo.
Does it print foo or not? Let's find out. So here, I'm going to have to go over to C because, of course, I'll show you what happens in Java. Here, I'll keep that done with the program or whatever. All right, there we go. Format that a little bit better and go into our course here. GCC demo. And there. I'm not positive that it's going to point that it might be smart enough to point out what's going on and wrong here. What I did there was I said, shut up, don't say anything, because no spoilers, right? With that W, right? All right, so let's run it. Foo, it printed out foo. Okay. What if I go outside of this bound? 15. Should it print foo?
Yeah.
It shouldn't, because 15 is outside the bounds of 0 to 10, but it does. Right? What if I go with negative 15? Yeah, still. What if it's 0 on the other end there? Still foo. It's always going to print foo, no matter what. Why? Well, let's now turn on the compiler warnings. I'll show you this to you in a second here. There you go. Comparisons of the constant 10 with Boolean expression is always true. Comparisons like x is less than or equal to y is less than or equal to z do not have their mathematical meaning. This is not math, this is coding, right? So what's ending up happening here? Let me go ahead and give you a value here, I don't know, 15. All right? What it's going to do is it's going to evaluate left to right. Right? Is 0 less than or equal to 15? Yep. It replaces this with something that is true. Let's just say 1. Now is 1 less than or equal to 10? Yep. So that's why it ends up outputting foo, right? And it's not correct math here, or it's not correct code. It's correct math, sure, but it's not correct code. What happens over here in Java if I try to do the same thing? The compiler is not even going to let me do it, right? I can change this to system.out.printf, but it's not even going to compile on this. Over here in C, it's just a warning because it's syntactically okay. It's correct syntactically. But over here in Java, they said, no. We want to avoid errors like that entirely, and so this is not only a warning, it is an actual compiler error. It is not highlighting this in yellow, it is highlighting in red. Right? So this is bad code, right? Why? Well, again, it doesn't have the same mathematical meaning. It compiles, it runs, but it does not get any intended result, right? And again, the reason is because you read it left to right. In Java, does not compile. Yay, good. What's the solution here? Let's rewrite this code to get its actual intended meaning of A is between 0 and 10. Let me go ahead and copy it and paste it here. So what should we do? Yep, break it up. Ampersand A, there we go. Right. Now generally, stylistically, you should you should not, in general, do the following. If A is if 10 is equal to A, right, then do something, ... Instead, prefer prefer variables on the left-hand side, LHS, left-hand side. So if A is equal to 10, right? I don't know I forget if we talked about this or not, but whatever. But this is the one exception to that guideline, or that, I don't even want to call it a rule because it's just a guideline. This is one exception that I would say, well, okay, if you're trying to check a range here, then the lower range should of course be on the left and the upper range should of course be on the right. And put the variable in the middle here so that it looks mathematical, okay? So, but this is okay. But this is probably okay. If you split that up, it would be very, very difficult to read. Right? All right, here's another example. In C, I'm going to set A equal to 10, or 5, excuse me, and I'm going to check to see if it's equal to 10. Nope, this is not algebra. What was my mistake right there?
Using the assignment operator.
Yeah, I'm using the assignment operator instead of the double equal sign. Let's see what happens over here in, not Java, because it won't be allowed, but let's go ahead and see what happens over here in, here, I'll just move this up here, right? And change it to 5, and then I'm going to reuse this print foo here. There. Right? So once again, no spoilers. All right, let me run this. Foo. All right. Again, what's happening here? It's reading it left to right. This is assigning the value 10 to A. Well, what value is 10? True. Therefore, the expression ends up being true. I'll prove it to you. After this, printf, A is now %d, and the line, A. Run it, and we see that A is now 10. It was reset using this assignment operator here. Right? What happens if we did something like this over here in Java? Again, compiler error. It's not going to let you do something like that. And if we had used a proper linter and not shut off that, oh, okay, fine. Let's go ahead and go all. There we go. Warning, suggest parentheses, or the parentheses suggest around the assignment operator is used as a truth value. Right? Suggest parentheses around the assignment used as truth value. It's just giving you a warning. There's something fishy going on here. It's one of those code smells, right? It smells like it might have gone bad, but maybe it's okay. But yeah, in this case, it's definitely bad. And again, the issue here is don't confuse the assignment operator, that is the equal sign, with the equality operator. Equals equals. Right? In Java, compiler error. Okay. One more. Yeah, one more, and then we'll talk about how to solve all of these things collectively, which I just showed you, but I'll explain what I was doing. Consider the following code. If A is equal to 10, then print A is 10.
Semicolon.
Yeah, weird semicolon there, right? When you get used to enough code, you start seeing the patterns in it, right? And you immediately see, wait a second, a semicolon? If you have good style to begin with, those things kind of stick out like a sore thumb, right? But what's going to happen here? Again, clear. No spoilers. Quiet you. All right. Very good. Oh, I guess I didn't declare it. It's not compiling. Fine. Int A is equal to 5. There we go. What's going to happen? A is 10? Ah. Why? It's not 10. It's 5. Well, what happens here is a secret that I wasn't telling you. You don't have to have curly brackets for a single statement, right? So if you were to write it like this, it would still work correctly now, right? But writing it like this, what is the statement that is getting bound to this? So we have a condition, and then we have the statement that binds to that condition, that code block that actually gets executed if that statement is true, right? Well, what's the statement that gets executed if this ends up being true? Nothing, right there, where my cursor is blinking right now. Because you can have as many empty statements as you want. Empty sentence, period, right? That's perfectly syntactically fine in code. It's terrible essay writing, but right, I don't know if it's syntactically correct in English, but whatever. Right? Now, putting in curly brackets like this is always best practice, because it doesn't matter if it's 1, 0, or 100 of these statements. You should always put your curly brackets there, because when you forget about them, then that's when you kind of start getting screwed because of bad code. Right? In fact, it wasn't a semicolon, but it was a missing colon in the software of the SSL software, secure software that check to see if you were going to the correct website, if they had the correct keys and stuff like that. There was one missing semicolon that basically for a dozen years or so circumvented by missing it, it circumvented all of these security checks. And people had been able to exploit it, who knows how many did, for a decade or so. Right? So one little thing matters. Right? Let's go ahead and get rid of this now. Now should it print out 10? Nope. Done with program because it's 5. Right? So again, the solution here, the above will compile and actually run in both languages, but it will give incorrect results. The semicolon means that the if statement binds to an empty executable statement. Just this statement right here under my cursor, which is empty. You don't have to have a statement if you don't want to. Right? All right, so how can you avoid all of these things? There's a very nice tool, at least in C, called a linter. Right? You can avoid most programming errors, or many, I should say, many programming errors by using the GCC as a linter. Right? So what is a linter? All right. Well, think about a lint roller. First of all, what's lint? Lint are little specks of fabric on your clothes, right? That your clothes are clean. They came out of the wash. They went into the dryer, right? That's fine. And most of the lint went down into the lint chute or whatever. But there's still a little bit on your clothes, right? And if they're fancy enough clothes, I don't wear fancy clothes, but if they're fancy enough clothes and you've got lint all over them, what do? You take the lint roller and you roll it over to collect all the lint. Because it's not dirty, it's not wrong, it's just those little things that probably should be taken care of. Right? And a linter is what is called a static analysis tool. Right? That is, static means that it checks code before it compiles. Later on, we'll look at dynamic analysis tools that check code as it's running after it's compiling. Right? It's dynamic because it's actually running. Static means that it's stasis, or it's static. It's not changing, right? Because it's written code. We haven't compiled it yet into machine code and changed it into machine code. We're just looking at the code itself, right? It can detect many code errors that should be addressed. Right? To do this, you can use the wall flag. This stands for warnings. Oops, sorry. Warnings. All of them. Did I do that right? Yeah, there we go. Wall, there we go. Wall warnings, turn on all of them. Okay? And that's what I was suppressing over here. This was shutting all of them off. So let's actually go ahead and reintroduce all of those errors into my C program over here. There we go. I'll go ahead and put that one there as well. That's not real code though, so I can't go ... There we go. And I'll also put up the other bad error up here. There we go. All right, so all those errors, if I had just simply used the wall flag here, then I would have been warned about all of them, right? That's not going to have the meaning that it should have. Oh, why is that not coming up anymore? Oh, because I corrected it. That's the correct version. There we go. There we go. Now I'm getting a whole bunch of warnings. Now note that these are all warnings. None of them are errors. It compiled. It'll run just fine. But it's going to give me weird results. Okay? But by using the wall flag as a linter, it's coming up with all of these warnings. Warnings, warnings, warnings. Now what about over here in Java? What is your warning system? Right? If it's compiling because it's not red, but you've got this thing right here. Right? This is a warning. It's alerting you to the fact that you have a local variable that's not used. Why did you declare this? You probably meant to use it, and so you need to actually write some code to actually use it, and I'm warning you about that. Oh, and then you look at it and say, no, I actually did not mean to use that. That was in a different version of my code. Fine, get rid of it. Get rid of that cruft. So you do have a linter over here in Java. It's just automatic. It's showing you all the warnings over here. Right? And the same over here. If you've got like another variable int x that is completely unused there, then I will go ahead and say, oh, warning. Where is it? There we go. Unused variable x. Right? Now, we've set up code post where you submit all of your stuff, including labs and hacks. And we've set it up so that it will run all the warnings in both C and Java. You need to address those warnings because it's now part of your design grade. Remember the rubric there? You've got like 5 points for design. Addressing all those warnings is one of those points that can be taken off. And it'll issue it loud and clear. Yeah, it compiled, it ran, maybe even all of the test cases passed, but you still have warnings in there because you have, why did you declare that variable there? Get rid of that cruft. Right? Okay. So that's what a linter is. Very nice tool to use. It's always best practice to do that. And there are other ways that you can run this as well. But all right, let's do our exercise then. I think I've simplified it to this. Okay, yeah. All right. Oops. There. So let's write a program that reads a decibel level. Decibel level is a measure of the loudness of noise, right? Of sound waves compressing in atmosphere from the user, and gives the user a description of the sound level. And I always do this in the fall as well because, of course, we've now had 2 games. And did they have a delay of game? No, they did, or they kept. You saw the photos of their quarterback like holding up his ears because he couldn't hear the microphone because it was so loud. So, if anybody was at the game, did they have an actual real? It's probably fake on the scoreboard. But what was the actual decibel level or reported?
A lot of people said it was about 100. Like a whole
Yeah, the
100?
scoreboard says 100.
All right, it says that no matter what.
I know I got a bunch of notifications on my watch being like, sound levels over 95.
Oh, really?
Yeah, I know it was at least 100 for like a few of the first drive when people were going crazy on third down.
Okay.
It's definitely 100.
So it was loud.
It was like
Well, it's probably not possible, but it can get dangerous, right? Eardrums pop. Or even beyond, I forget what the actual decibel level is, but compressive waves, explosions, those can become deadly, right? So you can have fatal decibel levels, and this is on a logarithmic scale, so it would be a lot higher than this. So what we're going to do is we're going to write a program that reads in a decibel level from the user or from the command line or whatever, and it's going to output a English term for that level. For 0 to 60, it's going to be quiet. By the way, there's no such thing as negative decibel levels. 61 to 70, that's conversational, like in here. There's a Husker game right there, loud. And then finally, it gets dangerous after that. So using that as a guide, or let's go ahead and write this program. I'm just going to go ahead and copy over demo to decibel. Is that spelled correctly? Decibel? Yeah, there we go. And let's go ahead and open that up. And once again, the very first thing I should be doing in all my code is author header. Me 2024 09 09. There we go. 9. Come on. All right. This program reads in a decibel level and outputs an English characterization of it. Right? There we go. That's all. That's really all that's needed there. Right? You don't have to get fancy. Probably not going to use any math. Probably not going to use any standard booleans. So I'm going to go ahead and get rid of that cruft. Right? Unused libraries are also a warning over here. If I don't have like a scanner here, import java.lang.scanner, right? And I don't use it, or where is it? Correct it. Not on lang, probably util. There we go. If I don't actually use that in my program, it is warning me about that. Get rid of those things. Right? Get rid of that croft. We'll need it later though. Right? So do we want to read this in as a command line argument, or do we want to read this in interactively from the user?
Interactive.
All right. Oh, I heard interactive louder, so going with the decibel level here, they went out, right? So please enter a decibel level, right? And we'll go ahead and read that in as a integer, double. Yeah, you can have fractional decibels, but it's not usual. So what do we want to do? Well, is it going to be an integer, decibel? Here, I'll go integer, or should it be a double? Let's decide that first. Integer, okay. All right. Does it say over here?
No.
Nope. So that gets into something that's you're going to get into much later in the curriculum called design or requirements elicitation. Right? You're eliciting whoever you're writing. Somebody's paying you to write this program, right? And they didn't specify what they wanted here. So instead of guessing, what we're going to do is we're going to go back to them and elicit more responses. Do you want to support fractional decibel levels? Yes or no? That gives us our answer. Does this program need to support decibel levels greater than 1,000? Yes or no, right? What, those kind of, you interview whoever's paying for this, the stakeholder, and you're getting your design out of them. Because 99 times out of 100, they're not going to know what they want, or they're going to make all these assumptions that they know that you know exactly how they want the program to run. And that's not how it works, because if you write the program and give it to them and say, oh no, this isn't supposed to support fractional numbers. Why are you outputting 60.5, right? Then it's on you, right? And this is all contract negotiations and such too, because once you write up the requirements, right, and then you go back to them and say, sign off on this or not, right? What else needs to be changed here? And if they say, nope, this is all looks good, you're in the clear, because if you deliver those requirements, you still get paid no matter what, right? As long as it's a contract. But if they screwed up because they didn't put they signed off on the requirements. However, if you didn't have that kind of process where you elicit a response and then go back and forth and decide on what the requirements are and what the design is, then it might be on you and you're not getting paid. Right? So let's just go ahead and leave it as integer for now. Is x a very good variable name? No. What does it represent? Decibel. So let's call it decibel. Right? Now let's immediately scan it in. Scanf %d is the placeholder for an integer, right? And we'll read it into decibel. Right? Right? And printf read %d and the line decibel. All right. Is that correct? Careful. Again, let's ask, not demo, decibel, right? Let's ask the compiler to check everything rigorously by issuing all warnings. Right? Warning, decibel is used uninitialized, and you've got a problem here. Format expects of %d expects the type or integer star, but has of type int. What is that thing that I'm forgetting there? That magic thing? The ampersand. Now, once I do this, both of those warnings go away because it is actually initialized by the scanf call, and I'm using an ampersand here. Right? Let's just run it and find out. Decibel level 10. Excellent. I read 10. I'm not going to keep this in here. Instead, I'm going to have an English version of this, right? Decibel level of %d is ... And now what we need to do is we need to write the code that actually gives us this English characterization right here. So if decibel is between 0 and 60, less than or equal to decibel, less than or equal to 60, then it's quiet. Yeah, why not? Yeah, that's one of those pitfalls we just discussed, right? It's going to read left to right, and again, if I issue a warning, tell me about all those warnings, it's going to say that doesn't have their mathematical meaning. So what could I do instead? Double it up, and, right? That's the first one, else if. Let's go ahead and grab this entire thing and just go ahead and blindly copy paste and say 61 through 70. 61 through 70. There we go. Then that's going to be, what was it, loud or conversational? There we go. Copy, paste, copy, paste, copy, paste. Already I'm getting into a bad habit here, right? Because I'm going to have to change everything. What was it again? 71 through 110. So 71 through 110. There we go. And then the last one is going to be 111 to 194. 111 to 194. Right? There. And it was conversation. It was dangerous, right? But me copy pasting, I didn't change everything in the correct order. I didn't change everything. Conversational, it should have been what? Dangerous? I don't know what. Loud. There we go. All right. So be careful when you're doing that kind of stuff. Okay? All right. Can we optimize this code a little bit more? Yeah, go ahead.
Do it in the reverse order and just check if it's less, if it's greater than.
Okay, well, I don't like thinking in reverse. That's good, but let's do your suggestion, but forward, right? So let's think about this here. If it falls between 0 and 60 inclusive, then it's quiet. If that's not the case, then we already know that it, for now, let's just say that we know that it's greater than 60. Do I need to check for it here? Nope. So how could I optimize this? Take that guy away right there. Right? I know that it's greater than 60, so it must be 60, at least 61. But if it's between 61 and 70, then it's conversational. I can also get rid of this one because I know that if I gotten to this point because of mutual exclusivity, only one of these things and the first one that is true gets evaluated, then I don't have to do all of these. There we go. All right. So testing. Give me something quiet, 20. There we go. Give me something conversational, 65. Right? Conversational. Give me something on the border, 110. That should be loud, right? Good. Give me something dangerous, 190. Right? There we go. Let's check on the other end. What was the other end on dangerous? 111. Let's make sure that we still get 100 dangerous on 111. Okay. So I'm convinced that what I have so far is correct, but you need to test rigorously. What are some things that I'm not testing? All right, let's go ahead and go with a negative. Negative 10. Is that conversational? No. So, if it's less than 0, what happens?
We need another conditional to say decibels can't be 0.
Okay.
Or less than 0.
If decibel is less than 0, printf error message. Error cannot be negative. Be negative. Enter. There we go. And we could exit right there, or I could just allow the fall through here to take care of it. Now I know that it's 0 or greater. Right? All right, now let's test that again. All right, negative 10. Okay, I fixed that one thing, but I changed my code. There might be some what are called regressions. In other words, fixing one test case, all those other test cases I did, 65, 111, etc., they may now be broken. And so I've got to go back and redo them all. 110, or 11, I guess. 110, 111, dangerous. Okay, that's good. I did 65, ... This is a very, very manual, labor-intensive process. We write code to automate these processes. So we should write code to automate the testing of our other code, right? And that gets into unit testing, which is something that we'll get into eventually. You'll have a very brief preview of it in your lab tomorrow because we've set up an ad hoc unit test for leap years, where you have to write this leap year function using this logic, and then we've written some ad hoc code that says 2000. Let's see, it's 2024. 2024 is a leap year. Let's test it. Do we get yes? Do we get true out of that? If so, that passes. Right? If we get false out of that, that fails, and we need to go back and fix it. Right? But writing code to automate those processes is going to be a lot better than me sitting here and trying all these possibilities, making a change, try them all again, making another change, try them all again, because there is still something wrong with it. What about that 1,000 decibels? It is blank. Right? Now, maybe that's that's what we would expect. I have no idea what that is, right? Because it was not specified by the requirements, right? So what should we do? We shouldn't just leave them hanging there. Let's give them a message. Undefined or something, right? I don't know. 1,000, undefined. Or you could give them a completely different message, and that would mean I would have to restructure this message up here to only print conditionally if it's correct. Or I would do basic error checking up here outside of this else if block. Right? Yeah.
Could you just use a switch statement instead of having a bunch of else ifs?
Switch statements are for equality only. They can't do ranges. And that's why I don't really cover them. We skip them in conditionals. Not only that, but in C, they can only ever be used for integers. In Java, they can only ever be used for integers or strings, and that's it. If we had instead made the decision to go with double. Nope. And by extension, because it's integers, it can do single characters in C. Right? Yeah.
What happens if you put a letter in?
Oh, good question. Let's find out. Hey, lots. There we go. It's quiet. Right? Why? Because it's interpreting this as 0. Right? Now, what you there? I think that's about all I wanted to do on conditionals. So there's nothing left today. But I will tell you that scanf. Actually, you can check for this kind of stuff. Let's go ahead and look up the documentation called RTMing. Read the manual. Read the manual on scanf. And reading the manual on scanf here is just me doing a Google search for it. Geeks for geeks is fine. Over here, if you're at the command line, you can go man scanf. Man is short for manual. RTM, read the manual. Or if you want to emphasize it, it's RTFM. Right? You can imagine what that means. All right, no, it's there. Read the freaking manual, of course. Right? It actually returns an integer. It will return the number of tokens that it actually matched. So in this case, if I gave it, 123, that's one token that it matched because it was a valid integer. And so we could capture that value, int matches, right? And we could check for it. If matches is equal to 1, right? Good input, right? But if it's not, if it's 0, that's going to be bad input. So we could issue an error message immediately. We're not expecting this at all in your programs, by the way, because CodePost is set up to only give you good input. Well, formatted input, I should say. Right? Printf, error, you should enter an integer. Because I have no idea what the hell they entered. Right? They could have mashed their keyboard or whatever. And so we're going to go ahead and exit on them right here. Clear this. GCC. Again, this goes beyond what we usually cover because we immediately get away from interactive input here. Everything from here on out mostly is going to be command line arguments. But a dot out, what did I say? A lot. There we go. Error, you should enter an integer.
What if you enter 0 now?
0 is going to be a matched token because it was it's a valid number. So we get past this, and then 0 is going to say, 0 is going to say quiet. Just like -10 is a matched token because that's a valid integer. Right? Good question here about 3.5. I think it'll work because it'll end up just treating it as 3. Yeah, 3. Right? But again, if I just mash my keyboard here, exclamation point, that stuff. Right? That's not an integer. So again, scanf can be used to return the number of matches. You just need to read the documentation. Int is the return value. This is not documentation. This is geeks for geeks. There. That's what documentation looks like. And, well, there's all the placeholders. We only talked about the placeholders like D, where's D? D or U, F for floating point numbers, a bunch of C for characters. There are a whole bunch of other placeholders. There are modifiers. Here's the return value. On success, the function returns the number of items or tokens that the argument list successfully filled. Right? And so if we only have one placeholder, we're expecting one value that it filled. Right? If we had 3 placeholders, you should not do that with scanf, by the way. But if you had 3 placeholders and it filled the first 2 but not the third, it would end up returning 2. I successfully did 2 of those 3 that you asked me for. Right? What else? If a reading error happens or end of file is reached while reading, the proper indicator is set, and if neither happens before any data, then EOF is returned. If an encoding error happens interpreting wide characters, then the function errorno is set. Okay, we can try that. Emoji smile. Right? So it'll probably just error out normally. Come on, there we go. Error, you should enter an integer. But actually some other errors actually occurred according to that documentation that we're just not seeing. We're not handling those errors, we're just saying that's not an integer.
Couldn't you ask it to print matches to see where it's returned?
What do you mean print matches?
In the if statement?
Oh, you could, I mean, you could ask it
Just to
to,
see where it's returned?
it will not have filled up decibel, so decibel will take on whatever default value it had, likely 0. But if I set it to 42, printf decibel is equal to, it probably never got changed, or if it did, it's just garbage now. Oh, thank you. Percent %D decibel. I was just thinking 42 in my head. All right. Yeah, it never got changed because it never filled it because it never matched.
What if you do just the character A? Give me like 32,000.
Nope, error. Right. Yeah.
So you have to do int matches and the seconds, or does it scanf change it? And then int matches checks.
Scanf will try to change this variable,
Okay.
but in my input, that's not match. So what it does is it doesn't do anything to decibel. It just immediately returns 0. I had 0 matches.
And if you put in like a real number, it would fill matches with 1.
It'll match with 3 and then ignore the rest of the input.
Okay.
Yeah.
If you did like 45A, would it just take a that?
Yep. 45A. It'll read up to 4, 5, and then, okay, I'm done, and give you 45. Yep.
If you put in A45.
A45. So you guys are doing what is called, sometimes called fuzzing or chaos testing, where you're just trying to give it as much garbage as you can to see what happens, and then okay, well if that happens, then we need to deal with it. It's called fuzzing. You throw as much crap at it as you can to try to break it. And in this case, it's going to be an error because it's A. Right? Again, we're going to get almost immediately away from scanf. You might have a few more exercises with scanf, and in your reading, they use scanf all the time. But the keyboard is terrible input because you cannot control the ID 10T user sitting there. Right? Right? The person that you say, please give me some valid input, they're just going to sit there and mash their keyboard. Right? You need to make sure that you are that you're writing programs that are not susceptible to the ID 10T user. Right? And so we're almost immediately going to get away from the scanf functionality. Right? All right, we'll pick it up there with loops starting on Wednesday.